So recall, these are the symbols we will be using to compare greater than, less than, or equal. In this problem, we're going to be comparing 3/5 to 4/9. The first thing we're going to do is multiply the denominator from the first fraction to the numerator of the second fraction, which is 20, and that's our product. So we're going to associate 20 with 4/9. And the second step is to multiply the denominator of the second fraction to the numerator of the first fraction, which is 27. So we will associate 27 with 3/5 and 20 with 4/9. So now we can just compare the products. So if we compare 27 to 20, we know that 27 is greater than 20. So we can do a greater than symbol. And that's it. Now we're going to be comparing fractions by second method that I mentioned earlier, which was to turn both fractions to decimals by dividing. In this case, we have 2/5 compared to 3/4. So now we're going to have to turn both of these fractions, 2/5 and 3/4, into decimals. So now we have 2 divided by 5, which 5 doesn't fit into 2, so we'll add a 0, we add a decimal point, and 5 fits into 24 times, which is 20, and that ends there. So now we know 2/5 equal to 0.4. Now we do the same thing to 3/4. We have to do 3 divided by 4. 4 doesn't fit into 3, we add a decimal point, we add a 0. 4 fits into 30 7 times, which is 28. We bring down another 0. 4 fits into 25 times, which is 20. 0, so 3/4 is equal to 0.75. So now we can compare 0.4 to and we can see that 7 is greater than 4, so 0.75 is greater than 0.4. Now we're going to go over method number 2, which says we're going to compare rational numbers by converting both fractions to fractions with a common denominator. So in this problem, we're going to be comparing 5/9 to 4/7. So we're trying to find a common denominator. We look at 9 and we look at 7. We can try and think of the least common multiple that they have in common, or we can just multiply both of the numbers. We can multiply 7 by 9, and we multiply the numerator as well, and 9 times 7, and also the numerator as well. So we end up having 35 in the top and 63 in the bottom, compared to 36 to 63. So now we can just look at the top numbers, which is the numerator. We can look at the numerators and we can compare which one is greater. And in this case, obviously 36 is greater than 35. So now we can see that 35 is less than 36. When comparing decimals, there is a common error that many students do. If you are going to compare all of the digits after the decimal as one number, you must make sure that each number has the same number of digits. For example, if I have 0.41 compared to 0.256, it would be a mistake to compare 41, which only has 2 digits, to 256, which has 3 digits after the decimal. If you do that, you would mistakenly conclude that 256 is greater than 41, which is wrong. When ordering decimals and fractions, it's a good idea to convert all fractions to decimals or to convert all decimals to fractions with a common denominator. In this case, we have 0.03, 4/5, 0.256, and 0.98 and 3/4. So out of all the numbers, it looks like the majority of them are already in decimal form. So I'm just going to convert 4/5 and 3/4 into decimals. And we can do that by using long division. So let's do 4 divided by 5. We add a 0 because 5 can't fit into 4. 5 can fit into 40, 8 times 40, and we have 0. So 4/5 is equal to 0.8. Now we're going to do 3 divided by 4. 4 can fit into 3, so we add a 0, and we add a decimal point. 4 can fit into 37 times. That's 28. Bring the 2, a 0 down, and 4 can fit into 25 times. So now we know that 3/4 is equal to 0.75. So now we can write all of our numbers in decimals. So we have 0.03, and 4/5, as we just did, was 0.8, and we have 0.256, and we have 0.98, and as we did earlier, 3/4 is 0.75. So like I just mentioned before, if we want to compare the numbers by looking after the decimal point, we have to make sure that all the numbers have the same number of digits. So let's add a 0 to the other numbers that are missing digits. So in this case, 3, we can add 0, 3, we add a 0. Then 0.8, we add 2 zeros. This one already has 2 digits after the decimal point. And to 0.98, we add 1 0. And 0.75, we add 1 0. So now we can compare them by looking at the numbers after the decimal point. So we're going to put these numbers from least to greatest. So we can begin by looking at the first number. This one looks like it's 0, so that one looks like it's smallest. So we can write 0.03. So that one's gone. The next biggest or next smallest is 0.256. So we've marked that out. The next number, 0.75. The next biggest is 0.8, and the largest or the greatest is 0.98. Now we can write this with our fractions included. We can do 0.03 followed by 0.256 followed by 3/4, then by 4/5, and then by 0.98. Sometimes just looking at the numbers is not enough, but a visual aid can help with that. And in this case, I'm going to talk about a number line. We'll approach it the same way like we did with the other problems. We are either going to change all the numbers into decimals or all to fractions. And so I'm going to change them all to decimals because I find that easier. So I'm going to change this into a decimal number and this into a decimal number. So we'll end up with here are our numbers in a different form. So now we can draw the number line. So now we can place these numbers within the number line. So I split this up into 10 lines, and you don't have to do this, but it can help. So 8.2 would be here, that would be 8.2, then 8.3 would follow. 8.99 would be really close to 9. This is 8.99, and 8.6 would fall around somewhere in between here. So right here, 8.6, and it's repeating. So now since we have those in the number line, we can visually we can see how the numbers are in order from least to greatest. So we can say the smallest, the least is 8.2, then 8.3 follows, then 8.6 follows, and the greatest is 8.9. And we can rewrite that if we want to, and back into the original forms. 8.2, and it's going to be 8 3/10, 8 2/3, and 8.9. That's our final answer. We know 1/4 is equal to 0.25, and 1/2 is equal to 0.5. So if we look at set T, 0.44 is greater than 0.5, so that one's wrong. Each number in set S is less than 0.65, which is not true because 0.8 is greater than 0.65. And each number in set T is greater than 1/2. Let's go to T. That's not greater than 1/2. We can go to each number in set S is greater than 0.5, which looks like it's true because 0.8, 0.6, 0.555, and 0.57 are greater than 0.5. So J is our answer.